Thank you everybody for giving me this opportunity to demonstrate photosynthesis using Derby Girls, and I think it's going to be really exciting, but we have to get it done before the end of October while we still have the summit space, because I don't think it's going to work as well at the Y. So I just wanted to give a little bit of verbal description of how hopefully this could work, and suggestions are always welcome. So this is my first idea on how to work it, and describe the different steps that we'd like to take to demonstrate photosynthesis using the hydrogens, the carbons, and the oxygens that are recruiting for this. So we want to start out by just pointing out that we need basically 12 different molecules. We need 6 carbon dioxide molecules and 6 water molecules. And so I'm hoping to be able to do some sort of leaf shape, hopefully with Warhol's help, to outline it on the floor with maybe some green duct tape or something. I'll rely on her artistic skills to do that just on the floor itself. And then hopefully our videographer can get at least high up enough to be able to see the images this way. So I want to be able to have hydrogens mostly be juniors if at all possible, and then the adult skaters be the carbons and the oxygens. And so we can start out with these triplets just randomly distributed on the floor, and then trying to sort ourselves out so that the water molecules will be coming in from, say, the base of the leaf, signifying that it's coming from the ground. Water is coming from the stem, and then the carbon dioxide will be coming in through the stomata, if you remember your school studies. And so we can put the carbon dioxide kind of around the leaf itself. And I think we could have the carbon dioxides arranging themselves around the leaf first, and then bring in the water molecules. And this is where it starts to get a little bit confusing on paper. So we want the water molecules to be able to sort of interact with the carbon dioxide molecules, right? And so I think it doesn't have to be perfect, but the idea is we want to create glucose. And I think that the easiest way to do that is we can do some bumping around. So have the oxygens that are with the water molecules kind of bump up against the carbons, and dislodge the 2 oxygens from the carbon dioxide, because that's the idea, right? When you introduce light into the leaf with using chlorophyll in the leaf, right, that's where we have this process taking place to form glucose. So bumping the oxygens up against the carbons and then knocking away then the 2 oxygens from each one of those carbons will be the easiest step. Now, here's where it gets a little weird, because 4 of the carbon dioxides can just directly, basically, will bump off those oxygens, and then the water molecules can arrange themselves around the carbons. So 4 of those are pretty straightforward processes, at least in our symbolic way of doing things. But then the other 2 carbons with the 2 remaining water molecules have to do something a little bit different. So one of the oxygens has to be completely separate, and then the 2 hydrogens that come from that oxygen, one needs to go to one carbon and the other one needs to go to the other carbon. And so it's a little confusing and hard to describe, but basically we want to be able to have bonds with the carbon atoms and yet have one of the oxygens be separate and linked to 2 of the carbons. So we're creating essentially that hexagon structure that you see in the lower left-hand corner with this offshoot of one of the carbons, and has 3 hydrogens and an oxygen attached to it. So it's a little confusing, and that's where I'm hoping that we can work out some choreography when we get on the floor with the videographer. But the idea then is we end up with this hexagon. One of the oxygens is going to be linked in that hexagon, and then one of the carbons with its 3 hydrogens and 1 oxygen is going to be kind of sticking off to the side there. And then the 6 oxygen pairs can sort of, spool off into the distance together, and I'm sure that'll end up being looking really cute. We have to demonstrate, though, the links to create that hexagon and that offshoot carbon. So we're thinking about maybe pool noodles or something like that. Otherwise, for the rest of those connections, we'll just be holding hands or trying to just demonstrate some simple connection with the different atoms. But with the carbons and that one oxygen, we need to find pool noodles or something to really show those bonds. So if you have some good ideas on the kinds of things that we could use to link those different atoms, that would really be helpful. The other thing is that once we get done showing this, and it will be narrated, of course, later on with a videographer, we want to describe the opposite reaction, which is basically the tree or any plant basically then uses that glucose as for energy. It's stored energy. So we'll be showing the respiration process as well, where we basically are taking this process and reversing it. So hopefully we might even, I don't know, we could just run it backwards, I suppose, in the video, but hopefully we can find a way then to break up the glucose molecule and reorganize into water and carbon dioxide, which really does happen in the plant as well. So thank you for listening. I hope this helps give you an idea just a little bit on what the complexity of this could be, but I think it's going to be a lot of fun, and I really appreciate everybody's help with it. So I hope to see you soon. Thank you.